There are many machine learning algorithms. Machine learning algorithms can be broadly classified into regression algorithms and classification algorithms. In classification, we try to predict the class or label of any data. Classification examples are like as shown. In regression, we predict the continuous value for any given set of feature on the basis of given dataset for modeling. Regression examples are like as shown. Basic difference between regression and classification is that the output in regression has many unique values as it is continuous. Whereas output in classification has only 2 unique values if it is binary classification, or it could be more. If it is 10-class classification, then output of classification model will be 10 unique values. Some commonly known regression models are linear regression, multiple linear regression. Commonly known classification models are decision tree, logistic regression, random forest, support vector classifier, and so on. The intention of model fitting is to minimize the error between predictions and actual labels during the learning process. Algorithm like gradient descent is used for minimizing the loss function or cost function. Let's now discuss about the loss functions in linear regression. So we feed the input features in linear regression. And then model follows the training process using gradient descent. To find the best linear combination of input features to predict the output variable. It is an iterative process which follows steps. First, model predicts the output. Second, calculates the difference or error between actual value and predicted value or label. In this way, gradient descent algorithm knows which coefficients of model to change so that this loss function reduces. This process keeps going on until no further learning can happen. The loss function used in regression is mean squared error, which is also called L2 loss. Other loss function is mean absolute error. It is also called L1 loss. Then there is Hubbell loss. This loss combines mean squared error and mean absolute error in single function. Hubbell loss puts more quadratic penalties to the model when it makes small errors and linear penalties when it makes huge errors. Then we have loss functions for classification algorithms. Classification can be binary classification or multi-classification problem. In binary classification, we need to predict for 2 classes. Whereas in multi-classification model we need predict for more than 2 classes. The common loss functions for classification models are binary cross-entropy loss, which is also called log loss function. Other classification loss functions are multi-class entropy loss, hinge loss, and so on. The loss function for binary cross-entropy loss can be written as cross-entropy loss increases as the predicted probability diverges from the true value or actual label. If actual value or y is 0, then loss function becomes negative of log of 1 minus p. Now if you see actual value is 0 for label, whereas if model predicts it to be 0, then log of 1 minus p becomes log 1, which is 0, and so penalty is also 0. Whereas think otherwise, if model predicts this label to be 1, then log of 0 is infinity. Which means huge penalty is applied to the model so that model tries to improve itself. Now let's look at hinge loss function. This loss function is used by support vector machines for classification. Now let's look at hinge loss. Hinge loss is a loss function that is used for the training classifier models in machine learning. You can see that it is max of 0 or 1 minus product of actual and predicted. The output class is 1 or minus 1. If actual class and predicted class is same, then product of actual and predicted is positive and penalty is less. Whereas if actual and predicted have opposite signs, then penalty is high. Hinge loss is basically optimized to maximize the margin between the classes. So to summarize which loss function to be used in our problems. Squared loss minimizes expectation. So pick it when wants to predict something like house price. Logistic loss minimizes probability. So pick it when wants to predict if market will go up or down. It is used when we need to get the probabilities for our predictions. Hinge loss minimizes the 0 or 1 or yes/no question. Pick it when you want a hard prediction and not probabilities.
Please share to all passionate people and all data science groups so they can come forward with some ideas for solving future problems. Comment below what ideas hits in your mind currently in the given scenario for helping the humanity. Once again, thank you and thanks to all those from whom I have learned this technology.